Okay, chemistry 2023. Let's look at the questions. Which subatomic particles are found in the nucleus of an atom? Remember, in the nucleus of an atom, we have protons and neutrons only, whilst the electrons are found in the orbitals or in the rings or the shells. So our answer is going to be D. Which pair of substances will react together? So here, looking at this, you can see that we have halide salts versus the halogens. So remember, the reaction is based on displacement reaction, whereby something that is more reactive displaces something that is less reactive, and then the reactivity of group 7 elements increases up the group. Okay, so that means chlorine is the most reactive, then iodine, then bromine, according to our question there. So now, what will be the answer? Option A says sodium. Let's just remove this. Okay, sodium bromide and chlorine, yes, those will react together because the chlorine is going to displace the bromide, because according to our reactivity here on this side, chlorine is more reactive than bromine, hence it can displace it. Okay, then here B, sodium bromide and iodine. Iodine will not displace the bromide in sodium bromide. Then C, sodium chloride and bromine. Bromine cannot displace chlorine because it's exactly the opposite of what you have at option A. Then D, sodium chloride and iodine. Iodine is less reactive than chlorine, so it will not displace the chloride ions in sodium chloride. So our answer is A. Number 24. Which row consists of gaseous molecules arranged in decreasing order of rate of diffusion? Remember, the link between diffusion and molar mass, or MR, is that the bigger the MR, the lesser the rate of diffusion. Okay, so in a way they are inversely proportional. Okay, all right, so let's look at our options. A, carbon dioxide, nitrogen dioxide, and oxygen. So now you have to actually calculate the MR of those gases because you're given the ARs there. So for CO2, remember, carbon is 12 plus this is 16 times 16, that's 32, so that is a total of 44. So that means that's for CO2. And then NO2, that's 32 plus nitrogen is 40. So you have to actually calculate this, because if you don't, then you might just randomly guess the answers. That's 46. And then lastly we have oxygen. That's 16, that's 32. Now we are told to arrange in decreasing order of rate of diffusion. Basically, the compound that has the largest MR is going to be at the end here, and then the one with the smallest MR is going to be at the beginning there. So that means we're going to start with oxygen, followed by carbon dioxide, followed by nitrogen dioxide. So our answer is going to be C. Okay, so that's DAC. DAC. Okay, the formula of ions of atoms of the elements in period 2 are shown. Okay, we have the ions there. Which statement about these ions is correct? Let's look at those statements, because we are guided by the answers or the options that we have there, not with the knowledge that we have. So that's how you answer paper 1. You follow the answers and then you work with elimination. They have, okay, A says they have full outer electron shells. They have full outer electron shells. Yes, that's correct. B, they have the same number of electrons in their valency shells? No, they don't. They do not. They have same number of electron shells? No. Remember, electron shells, they are guided by the period. Yes, if they were on the same period as elements or as atoms of elements, then that statement would have been correct. But now remember, depending on their group number, they are going to have to either gain an extra shell or lose an extra shell. Okay, so metals would lose electrons in the last orbital, so that means they will have one less, or two or three less shells. And then for these guys, they gain electrons maintaining that outer shell. Okay, so this one is out as well. They have same number of protons in their nucleus? No, they do not. So our answer is going to be A. 26. Which reaction is endothermic? Which reaction is endothermic? Endo means, remember, we are releasing energy to the environment. Okay, so sorry, we are absorbing, quite the opposite. Okay, endo means absorption of energy from the surroundings. So your delta H is going to be positive, whereas the opposite is exo, we release energy to the environment, so negative delta H. Okay, so our answer there is going to be photosynthesis. 27. Which action will increase the rate of reaction between calcium carbonate lumps and aqueous hydrochloric acid? Now we're increasing the rate of reaction, so diluting will not help us. Cooling the reactant will do the opposite actually. Crushing calcium, correct, because we increase the overall surface area of the calcium carbonate. Okay, decreasing the volume of the reaction. Now that does nothing. Okay, so our answer is going to be C. Number 28. The ionic equation for the reaction of magnesium and copper 2 sulfate solution is shown. Okay, we have a reaction there, and then the question asks which particles are reduced. Now, remember, oxidation or redox is defined in two ways. Okay, we have definition based on the gain and loss of oxygen, and then the other one is based on the gain and loss of electrons. So here we see that you have atoms and ions here, which change. You see this Mg changes from an atom to an ion here. So that means we have this definition here. Okay, so we're going to be using the definition of gain and loss of electrons. So let's follow that. Which particles are reduced? Remember, reduction is what? Remember, reduction is, so we use oil rig. Okay, so reduction is gain of electrons. What gained electrons there? Naturally, when metal atoms form ions, they lose electrons, so the reverse of that will be reduction. Okay, whereby a metal ion gains electrons. So you have to start with an ion and then you form an atom. So our answer is going to be the copper 2 ions. They're the ones that are reduced. Number 29. What is the formula of chlorine? Sorry, what is the formula of chloride of manganese, in which manganese has the same charge as that? So here, just the reverse. Remember, MnO2. So that means we have an 2 minus here, right? And then here we have 2 times a certain number which we do not know. Okay, in such a way that after you cancel the electrons of these charges, so this is going to be positive, so you have 2x positive, in such a way that when you divide it by this, when you divide it by 2 negatives, you still get 2. Okay, so that means we have 4 positive charges, in such a way that when you divide them by 2 negatives, this pair up, and then you're left with this 2, which is the 2 that we have here. So that means our number there is going to be 4 plus. Okay, So so if that's the case, that means Mn is 4 plus, and then chlorine is in group 7, so it forms Cl minus ion, and then you cross, then you form Mn Cl4. So our answer is going to be B. Our answer is going to be B. Okay. The diagram shows a setup used in the electrolysis of copper 2 sulfate solution. Okay. We have electrolysis there of copper 2, aqueous copper 2 solution. Which ion is discharged at the cathode? Now we're only concerned about the cathode, but first let's just remember the cathode is negatively charged, so it's going to attract positively charged ions. Okay, it's going to attract positively charged ions. Then what do we have? Remember, in aqueous copper 2 sulfate, you have ions from H2O, and then you have ions from copper 2 sulfate. Now from copper 2 sulfate, you're getting copper 2 plus and SO4 2 minus, and then from water you're getting hydrogen ions and hydroxide ions. Now since we're only interested in the positively charged ions, so we're only interested in this guy and that guy. Now according to rules of discharge, what happens at the cathode is that you follow the reactivity series. So borderline here is hydrogen, then here we say we have less reactive metals, your copper, your silver, your gold. And then at the top here, what do we have? We have more reactive metals. Okay, at the top part, you have your group 1 metals, things like sodium, and then somewhere in between there you have aluminum. This is just for reference. Of course, you will have to look up the full reactivity series. Then iron is somewhere there, and zinc, etc., etc. So now according to the rules of discharge at the cathode, what's going to happen is that we discharge whenever you have hydrogen and something that is in this bracket here, you discharge that thing. Okay, if you have a combination, you will always have a combination of hydrogen ions and a metal. Hydrogen ions and a metal. Now when you have a combination whereby it's a hydrogen ion and a less reactive, or a metal that is below hydrogen in the reactivity series, like in this instance we have copper, so that means we're going to discharge copper. We discharge what? Copper 2 ions. Now what about a situation whereby you have a metal that is above hydrogen in the reactivity series? Then you ignore that metal. Okay, those are the rules of discharge. You ignore those metals and discharge hydrogen ions. Okay, you discharge hydrogen ions. Okay, let's move on. So our answer here is, of course, A. Which statement about chlorine is correct? It bleaches damp litmus paper. Yes, it does that. It forms a white. No, it does not. It realize. No, it turns damp red litmus paper blue. No, actually the opposite. It turns a blue litmus paper red. Okay, because of those. Whenever you dissolve chlorine in water, it forms two acids. Okay, hypochlorous acid and hydrochloric acid. So those are acids, so they will turn a blue litmus paper red. The same way you would test for acids. So our answer there is going to be A. Now the hypochlorous acid is the one that is responsible for the the bleaching. Number 32 says, which equation represents a precipitation reaction? Precipitation reaction is whereby you have two soluble compounds that react together to give you one insoluble compound. To identify this insoluble compound, the state symbol is going to be solid. Is going to be solid plus a soluble compound, which is going to be written aqueous. And then these two guys here, if something is soluble, it's written aqueous. Aqueous means something has been dissolved in water. Okay, So let's look at the options that we have here. Let's say you have barium nitrate. All nitrate salts are soluble, so we have that, we can tick. And then we have this sodium sulfate. Okay, that's soluble. Then yes, this will come out as a precipitate, because remember, barium sulfate is insoluble. Okay, then this guy is soluble. So already I see my answer there, but let's just confirm the other answers that we have there. Now there's no solid product here, so a precipitate, it's a solid substance that is inside a liquid. That's what a precipitate is. So that's what we are looking for as our one of our products. So we don't have that here. Then this is not a precipitate. Okay, that's just a displacement reaction. Okay, it's a displacement reaction whereby the zinc just displaces the copper out of aqueous copper to sulfate. Okay, so this just is not a precipitate. Your precipitate are going to be salts. Okay, salts are the ones that are considered to be precipitate, while this is just a metal. Okay, that's just a metal. Okay, number 33. What is the empirical formula of the organic compound there? Remember, empirical formula, it's a summarized or a factored down molecular formula. So CHO, that's the general structure, or that's the general way of putting your carbon, hydrogen, and oxygen. Now we just count how many carbons do we have. We have 2. How many hydrogens do we have? 1, 2, 3, 4. And then oxygen 1, 2, 3, and then we divide by a factor. So 2 PA1, PA1, PA2, PA1. So you get C1. You don't have to write the 1. H2O1, just O. Then we identify our answer. Our answer is going to be A. Okay, so let's just write the answer A. What is the concentration in moles per cubic decimeter of 250 cubic centimeter solutions containing 0.5 grams of sodium hydroxide? Okay, containing. Okay, now remember, this is our formula. Concentration equals to moles. Let's just write N over volume. What do we have? We do have the volume. We just need to change it to the right unit. And then do we have the moles? No, but we do have the mass of sodium hydroxide. So to do that, your triangle for calculating moles, mass, AR or MR, depending on the compound that you have. Therefore, N is equal to mass over MR, which is equal to, our mass is 0.5 grams all over. We are given the MR, so we don't need to calculate it, over 40. Okay, then we do the calculation. Okay, now 0.5 divided by 40, that's 0.012. Oh, let me just write it somewhere else. Equals to 0.01225. Okay, so that's those are our moles. Now we're going to take that number and divide it by our volume. Remember, our volume is in cubic centimeter, so that means we'll have to do what? To convert it to cubic decimeter. What do we know? We know that 1 cubic decimeter is equivalent to 1,000 cubic centimeters. Okay, so we're just going to divide the 250 divided by 1,000. Okay, then we just do it once here. You have a calculator, so you just do it in your calculator. Divided by, so 0.0125 divided by 250 over 1,000. Okay, so what do we get? 0.05. So our answer is going to be D. Our answer is going to be D. A, D. Number 35. Which statement explains the unreactivity of aluminum metal? Remember, it doesn't react because it has what? A coating of aluminum oxide, a very, very strong oxide layer. Okay, this prevents any further reaction of the fresh aluminum with oxygen or anything that can be corrosive. So when you have aluminum, you have something like this. On the outside, you have this oxide layer, which stops any further oxidation by atmospheric oxygen. Okay, then this aluminum remains fresh. Fresh means it remains as the aluminum metal, not bonded to any other species of atom. So that's our answer there. And then number 36. What are the types of oxide formed by aluminum, sodium, and sulfur? Remember, aluminum forms an amphoteric oxide. Aluminum forms amphoteric oxide. So we'll take anything for amphoteric for aluminum, this, that. So we remove these two. Then sodium forms a basic. So we take this, not an acidic. And then sulfur forms an acidic. So our answer is going to be D. Okay. Remember, we have different types of oxides. Okay. Generally speaking, group 1 and group 2, as well as some transition metals, will form what? Basic oxides. Okay. Then after that, we look at the opposite of basic, which is acidic oxides, and that is given by non-metals. Okay, generally by non-metals. Note that I'm saying generally because it doesn't apply to all the oxides, okay, but majority of the oxides. Then we have neutral oxides. Neutral oxides are things like H2O and CO, okay. And then lastly, we have amphoteric. Amphoteric are those that behaves somewhat like basic, and at the same time, depending on the situation, they will also behave like as acids. Okay, so those are aluminum and zinc, as well as others, but for our syllabus we cover those: aluminum oxide and zinc 2 oxide. Okay, let's move on. 37. Which group of organic compounds can undergo addition reaction? So those are the alkenes. Okay, now to do addition reaction, you need that double bond so that you can break it down to create, you have initially you have something like this. Okay, you have something like this, just an example. Now here, when you have this double bond, you can break it down in such a way that you create room here. Okay, we've created extra space. Now we can add things onto this space. Okay, hence why we say this is addition reaction. You break this double bond, creating room for the addition of other species of compounds. Okay, yeah. Okay, and then so our answer is D. Which polymer has ester linkage in its structure? Remember, an ester linkage is the one that is COO, right? That's the ester linkage. Okay, COO. So the answer is not carbohydrate. Okay, it's not protein. It's not nylon. Now, nylon and the proteins have a similar type of linkage. Okay, they both have the amide linkage, the one with the nitrogen. Okay, the nitrogen. So our answer is going to be D. Okay, the answer is going to. So carbohydrates, it doesn't have a specific kind of linkage. The linkage that you find in carbohydrates is not really particular. You don't have a special name for that linkage. An oxygen there, bonded between two glucose molecules. We have the reaction there. Number 39. The reaction shows the reaction in which a simple sugar is produced. What type of process is shown by the equation? What do we see there? I see that compound there this reacts with the water. Yeah, so whenever you have a reaction that involves water being added to a compound, then you have hydration. Hydration. Okay, if you're adding water, then you have hydration. If you are breaking down a compound using water, then you have hydrolysis. Okay, if you are breaking, then it's hydrolysis, like electrolysis. Remember, electrolysis is the breaking down of ionic compounds, and then same here applies. If you have a large organic compound that you are breaking using water, like the digestion of carbohydrates to glucose, then you have hydrolysis. But if you are creating a compound or forming a compound by adding water onto a reactant, then that's hydration. Then last question, the table shows the results of tests carried out before and after boiling on water samples X and Y. So we have our data here. So you have to go through that. Now this is the soap test. Okay, this is the soap test. Before boiling, sample X we needed 10 drops of soap. Then after boiling we just needed 1. Okay. As for Y, we needed 1 at the beginning and we needed 1 after boiling. Which salts are most likely to be present in X and Y? So for X, what do we note there? We know that we have temporary hardness in water here. Why? Because temporary hardness in water is the only one that you can solve by doing what? By boiling the water. Okay. So X, we're going to make it with this guy, calcium hydrogen carbonate, because that's the compound that is responsible for temporary hardness in water. Whereas for Y, it's relatively soft. So you just need 1 drop to form leather, so it's relatively soft. So besides the only option that we have there is sodium chloride, which is actually correct. So our answer is going to be B. And then you get your 110%. Okay, I'll see you on the next one.